Hey, Topping Airlines Math and History, and we're going to be learning about what a linear function without a graph is. In the last few videos, we have been doing a lot of graphing, and we have been also discussing how slopes and lines on a graph relate to what a function is. But what happens if we don't have that graph? What happens if we are given a table and an equation to play around with? When we use graphs, we can clearly understand what kind of function it is. It could be a quadratic function, a linear function, any other kind of function. Graphs can help us visualize what the function will look like as if you were drawing a line, like a linear function is a straight line. But what happens if we can't use that graph? There are many other ways to represent a function. There is a table and an equation. These are the two most common ways to understand a function, and these are also the most two common ways when you are inserting the plots on a graph. When you want to find if a function is linear, you might want to ask yourself, how do I find that on a table, and how do I find that in an equation? Let's take a look at the ratio table first. So, the ratio table that's colored in purple can represent a linear function because what we're trying to measure is how far from 5 to get to 10 and how far from 1 to get to 2. It keeps going up by 1, 1, 1, 1. And on the right side, it goes by 5, 5, 5, 5, 5. So that can tell us that there is a steady rate or there's a steady change. Because if this is going up by 1 each time and this is going up by 5 each time, we can understand that it is called a linear function. We can have these points on a ratio table be put on a graph and it will be able to be in a straight line. But what happens if you see a ratio table that looks like this and it's not easily seen as a stable pattern? What are you going to do about that? What we're going to try and do is calculate the rate of change because we were calculating the rate of change for this purple graph. We noticed earlier that it was changing at a steady rate, and that's what we're going to try and do for the blue ratio table. See if the points are changing in a steady rate. So the formula is the rate of change is going to equal the change in y, divide that by the change in x, because the triangle symbol means change. And if you want to say that in Greek mythology, it is pronounced as delta. The person that found the word and the letter delta, the symbol for change was originally going to be the pi symbol, but since that was already used for 3.14, he decided to use that for a new Greek letter, and it was delta. That's the official symbol for change. So what we want to do about that formula is find the distance from here to there, or the difference, and the difference from here to here, and from here to there, and from 0 to 12. The distance or the difference from -2 to 0 is 2, and the difference from 0 to 3 is 3. The difference from -8 to 0 is 8, and the distance from 0 to 12 is 12. So we have found what the distance is and the differences between each number in a row. Since we found all the distances and the differences, now we get to use the formula, the change in y divided by the change in x. On a ratio table, your y is going to be on the right side of the ratio table, while your x is going to be on your left side. So what we're going to be doing is have 8, divide that by 2, is going to equal 12, divide that by 3. The reason why we did that is because we're trying to calculate and see if our ratio table and our function is changing at a steady rate, just like this one. So, if we have numbers that will equal to each other, that is going to tell us that those numbers mean that the ratio table is going to move at a constant pace. So, following the formula for a rate of change, the change in y divided by the change in x, 8 divided by 2 is 4, and 12 divided by 3 is also 4. And since 4 equals 4, and they're both the same, that tells us that this blue ratio table is a stable function. And it also means that it's a linear function, because when it changes and when it's going up one by one, that means that the change and the rate is going to be the same. We can actually list out more plots and points on this ratio table, and when you do that, it would still have the same rate of change. But what happens if it doesn't work? What happens if a number does not equal the same number, and if they're different? Here's an example. So, here's an example where this ratio table would not have a matching rate of change. So let's find the difference. 5 and 14, the difference is 9. 14 and 22, the distance is 8. The distance between 1 and 4 is 3. And the distance between 4 and 6 is 2. Now, let's use the formula and see why it doesn't work. We have 9 divided that by 3 is going to equal 8 divided that by 2. So 9 divided by 3 is 3, and 8 divided by 2 is 4, and 3 does not equal 4. This will not work because the rate of change is not a stable change. It's not in a steady change, which means that this is not a linear function because it's going to have a different change. Like, you can have a function like that and change like this. The red line is not a linear function, for example. So, we have now learned how to find the rate of change for a ratio table. Let's move on to an equation. So when you're looking at an equation and you want to find if it's a linear function, these are actually a big giveaway, because what kind of equation is actually going to draw you to understand if it is a linear function. Because when you see these types of equations, y equals 3x plus 8, those kind of equations are y equals mx plus b form. Or another way of saying it is slope-intercept form. We'll talk about that in the next video. So, we can understand that this one, y equals 3x plus 8, is a linear function. Because when you graph this in the graph, the number 8 indicates where you are starting. So we're going to start right here. And y equals 3x. That's telling us that we go up 3 and 1, 1. 3, 1, 3, 1, 3, 1, 3, 1, 3, 1, 3, 1, 3, 1. And when we do that and put the points on a graph, we get a straight line. So this is an example of a linear function. The equation and the structure of the equation is going to be a big giveaway for it. But when you see equations that look like these, this is not a linear function because we have an x squared. The squared is gonna basically ruin the whole equation. Instead of this being a straight line, it's going to be called a parabola or a function on a graph that will look like a giant U. When you are working with equations and you want to find if the rate of change is a stable rate, then you'll probably be incorporating ratio tables in your assignments. So when you have an equation, you'll incorporate a ratio table because the equation is telling you what to insert in for x to get y, and see if you put them in your ratio table, if the differences are going to be the same, or the rate of change is going to be the same. So, we have now understood how to find a stable rate and a linear function in an equation. Thank you for watching Tao Penalized Math Industry. Like and subscribe. And I hope this video has helped you.